Hi everyone. Today we're going to study limit of a function. On this topic, we need to define some terms. Number 1, variable. We say that variable is a letter or symbol that may assume any value. Examples are x, y, z. But the most commonly used variable is the x. And this x can assume the values like 5, -20, or 0, 100, 3/4, and any other real values that we can think of. Next thing to understand is the symbol x arrow a. X here is a variable and a is a constant. We read this as x approaches a. The variable x is coming closer and closer to a, but not necessarily mean equal to a. Example, x approaches 3. Let us draw a number line and identify the location of the number 3. And here it is. Now, let us consider those numbers that are coming closer and closer to 3. I'm not referring to the numbers 2 and 4, but those numbers that are really close to number 3. I'll put one example. 2.9. This 2.9 is close to number 3. I have another example, and that is 2.99. This number is closer to number 3 than 2.9. If I think of another number, I will write 2.999. This number is closer to number 3 than the two numbers mentioned before. I'm going to write 3 more examples, and the numbers are 2.99999, 2.99999, and 2.999999. I hope you can see a pattern on this. I can continually put more examples by following the pattern. Take note that these numbers are coming closer to that number 3 from the left side. Now, there are numbers that are coming to number 3 that will come from the right side. I'll put one example. 3.1. This number is close to number 3. I'll put another example, and that is 3.01. This 3.01 is closer to 3 than 3.1. Another example is 3.001. This 3.001 is closer to number 3 than the two numbers mentioned earlier. And I can put 3 more examples, and these are 3.0001, 3.00001, and 3.00001. I hope you can see a pattern, and we can put more examples following the pattern. Take note that this group of numbers are coming to number 3 from the right side. Now, the symbol x approaches 3, referring to the two groups of numbers that are coming to that constant 3. To be specific, for that group of numbers that are coming from the left side that comes to number 3, we're going to use this symbol, x approaches to 3 with an exponent negative sign, while the group of numbers that will come to number 3 from the right side, we will use the symbol x approaches 3 with exponent plus sign. Next term is the function. We had a 1 semester long period to discuss about a function. We learned this from the pre-calculus subject or pure math course. Let us write some examples of the function. I hope you still remember we have linear function, quadratic function, trigonometric function, logarithmic function, and all the other functions that we studied. The function is symbolized by f of x. Sometimes we have g of x or h of x. We are now ready to discuss the limit of a function. Let f of x be a function of x. If the values of f of x can be made as close as possible to capital L by making x close enough to a but not equal to a. It is denoted by lim f of x as x arrow a equals capital L. This expression is what we're going to see every now and then when we study calculus. We read this as the limit of the function f of x as x approaches a is capital L. Let us see example 1. Given the function f of x, the function is represented by this graph. We call this a piecewise function. This is the first piece. It is a straight line, and at the end is a hole. Another piece is like half of a parabola. It starts from here with a solid dot and it goes up. Another piece of the function is this graph that goes down. It's like half of parabola also, and from here there is a hole, and part of the graph is a solid dot here. And then the graph is continued from this point up to this point, and when it reaches this point we have a solid dot that we can see, and then another line that goes down and ended when x equals 3. So let us have the limit of f of x as x approaches 1. This is our x-axis. The number 1 value is here. So when x approaches 1, let us observe where is the height of the graph. We can see that the graph is coming to a point to that y value when x value is coming to 1. And when we consider the left side and the right side of 1, the graph is also coming to a single value, which is 1. So the answer here is 1. We can say that the limit of the function is the height of the graph, or y value, when x approaches the specific value. In this case, it is 1. Please note that the f of 1 equals 4. That is the point. Letter B, the limit of the function as x approaches 2. The number 2 value of x is here. Now let us observe the graph. It is coming to a value of y at this point, and the answer is 3. And we take note here the f of 2 is equal to 3. So these are the answers for example 1. Let us have example 2. Given the function y equals x squared minus x minus 6 all over x minus 3. Let us graph this function. The graph is a straight line, but there is a hole when x is equal to 3. Let us evaluate limit of the function as x approaches 1. Looking at the x-axis, the x value is here. And now let us observe what is the height of the graph when x is approaching 1. And the answer is 3. So we write here 3. We take note that the f of 1 is equal to 3. Letter B, the limit of the function as x approaches 3. Looking at the x-axis, number 3 is here. Let us check the y value when x is approaching number 3. And the answer is 5. In here, we take note also that f of 3 is not equal to 5. These are the answers for example 2. I hope you learned something from this video. See you again next time.